write down formulas that relate with the topic we were dealing with. So formulas like angular velocity, please, I want you to pay attention very well. What is disturbing us?
Keep quiet. This mic is even on. Keep quiet.
So formulas like angular velocity, formulas like centripetal force, formulas like centrifugal. I told you guys to write them down because we'll be applying them. So, and we started applying these formulas in the last class. So one of the problems that we solved was this. So for the sake of those of you that were not around now, it's just a refreshing. I remember that we did not solve everything. So if you were in the last class, please pay attention very well. If you were also absent, please pay attention. You will learn something now. So these are the formulas that we put down in the last class related to circular motion. Once you are dealing with circular motion, just know somewhere you will have your angular acceleration or angular velocity, centripetal force, and centrifugal force. Okay, so I have explained what all these things mean, the difference between centripetal force and centrifugal force. Now, how do we apply those formulas in solving problems? Problem number one: a body of mass 2 kilograms. Remember, I keep telling you in every class in physics that you pay attention to parameters you are given in questions, the values you are given, what they represent. Okay, the question has just mentioned mass 2 kg. You write it down. Mass 2 kg moves in a circle of radius 0.5 meters. Radius, radius, you write it down at 4 meters per second. Meters per second is velocity. So 4 meters per second is the velocity you have been given. You write it down. Find the centripetal force. Now, if you come back to the formula, the question is asking you to find centripetal force. If you come back to the formula now, look at centripetal force is mv square over r. That is mass times velocity square time over radius. Mass times velocity square over radius. So since the question is asking for centripetal force, I come back to the question. All right, and I write my formula. My formula is mv square over radius. That is mass times velocity square over radius. What's the mass given in the question? 2 times, what's the velocity? 4 meters per second, right? That is 4 square. Velocity square, 4 square. You must not forget the square. Don't just write 4. No, that square is part of the formula. Okay, it's supposed to affect that velocity. So 2 times 4 square divided by radius. Radius is 0.5 in the question. So the rest is just calculations, mathematics. 2 times 4 square is 16. 2 times 16 is 32. 32 divided by 0.5 will give you 64 Newton. Is that taken? Any challenge with this question now? We have solved this question in the last class. Okay, any challenge with this question? So that you
No,
can...
sir.
All right, no challenge. Okay, so you are welcome. Let's move to another kind of question that you can have now. This question says that a wheel, a wheel rotates, a wheel rotates through 10 radians, okay, in 2 seconds. Angular velocity is radians per second. It's not meter per second. It's linear velocity that is meter per second. V is meter per second. Angular velocity is not given in meters per second. So a wheel rotates through 10 radians in 2 seconds. Find angular velocity. Remember that this symbol, okay, represents angular velocity. Look at it here. Angular velocity, omega. You can see they just said you should find, and they wrote the symbol there, which means they expect that you know that that symbol represents angular velocity. And if you look at these formulas now, what's the formula for angular velocity? Theta over time. Your time must be in seconds. Theta is in radians, not in degrees in this case, although I remember telling you that I will show you how to convert from degrees to radians. Okay, in case you are given the value of theta in degrees, what do you do? How do you convert it from degrees to radians? So, but directly you have been given the value of theta here in radians, so you don't need to convert again to degrees. So I'm going to solve now. Solution. So I've been given theta in the question. Theta is equal to 10 radians, 10 radians, and time. Your time must be in seconds. If it's not in seconds, please, you must convert to seconds. Don't forget 2 seconds. So my formula, of course, you already know the formula. The formula for angular velocity in this case now, formula for angular velocity is theta over time. That is radians over time taken. Radians over time taken. So, and radians, you have 10 radians. Time 2 seconds. 10 over 2 will give you 5 radians per second. Very simple. You have just solved the question. Okay, this is how you calculate. Don't forget, this symbol represents angular velocity. Angular velocity. Don't forget that, please. Angular velocity. Formula for angular velocity is theta over time. Theta is in radians. Radians, not in degrees. You know, we normally refer to theta as an angle, right? In mathematics, theta is angle, always in degrees. But in circular motion, is in radians. So if you are given in degrees, you convert to radians. I will show you how to do that. But do you have any challenge with this question? This with my solution to this question now? Any challenge, please? If I give you a similar question, you can handle it, right?
Yes, sir.
Okay. So let me give you a question now. Let me give you a question. A fan, okay, that is fan, like can be ceiling fan or standing fan. The blades now, just talking about the blades. A fan rotates through
So please,
a
can you
fan.
help us write out the question in the end?
What if I choose to dictate? That is Emanuela Abi.
Yes, sir.
You are welcome. Oh yeah, let me write it. Uh, a fan rotates through 5 radians in 10 seconds. What's the angular velocity? Even if I just say what's the velocity, as long as it's a circular motion, you know that they're asking for angular velocity. Please don't forget. If I just say what is the velocity, as long as it is for a circular motion, they are asking for angular velocity. Don't forget that. So you have to look at the kind of motion you are dealing with. Okay, this is the question. Can you see it?
Yes, sir. It's 1/2, 0.5.
Okay. Others, I'm waiting for your answer.
Is 0.5 radian per
0.5. Okay, yes, next. Vera.
0.5
Is Vera?
per second.
Okay. Okay, good. 0.5 radians per second. You can see it's very simple. Physics just it demands that you just know the kind of question you are dealing with. If you know the kind of question you are dealing with, and you know which formulas are associated with this question, before you know it, you are through with the question. All right, let's move on. Let's move on to another kind now. Let's see. A fan. Let me enlarge this thing so that you can see it. I've already solved this, but let me show you how. A fan increases speed from 2 radians per second to 10 radians per second. No, they are giving you two angular velocities now, which are 2 radians per second and 10 radians per second in 4 seconds. Okay, the which means the initial velocity, the initial angular velocity, angular speed of this fan is 2 radians per second. The final is 10 radians per second. But the time taken to achieve this speed is 4 seconds. Find the angular acceleration. You can see if you come back to this place now, what's the formula for angular acceleration? Is angular velocity, that is change in angular velocity over change in time. You know, delta, this delta W here, this symbol that looks like W, it's not W, it's omega. Okay, we call it omega. Now, delta omega is the same thing as change in angular velocity. Delta T is change in time. Change in time. So let's come back to our question. So what are we given? We have been given two angular velocities there, two angular velocities, which we are going to make use of now. So let's go ahead. Our change, since my formula is change in angular velocity over time, so my change in angular velocity is equal to, you find the difference between the two velocities, okay? That is what it means. Change, delta, if you have done other mathematics, 10 minus 2 will give you 8 radians per second. So that is delta omega. Then change in time, you are given time to be 4 seconds. It means it took 4 seconds for this to happen. So you are true. Just write your formula, put those values there. 8 over 4 will give you radians per second square. Don't forget, acceleration is always square unit for time. Acceleration has square unit for time. That's why it's radians per second square. It's very simple. Once you know the formula, you find the values in the question, you input them in the formulas, and you get your answer. It's straightforward. These are UTME questions. Okay, they look very simple, right? Yeah. Any challenge with this one? Any challenge? Yeah, we have to
No,
be
sir.
passed.
Okay.
No, okay, okay. What if now, let's go back to the previous question. You know, we solved the question like this. What if you are given the angular velocity and a question is asking you to find the angle? For instance, the question is asking you to find the angle and you are given angular velocity and you are given time. You are given time, you are given angular velocity. The question is asking you to find the angle through which that particular object rotates. What are you
At
going to do?
20. Mm. We
No,
cross
just tell me the
multiply the time.
formula. Okay, very
It's
good.
going
You
to be
cross multiply.
angular
Angular
velocity
velocity times time.
equals to this thing, the theta over time.
Okay, listen to my question. No, listen to my question.
Okay, sir.
Let's assume you are given angular velocity already in a particular question, and you are given time, and the question asks for angle of rotation. Okay, how do you calculate the angle? You have angular velocity, you have time. Find theta. What do you do?
So I see from the same formula now.
What do you do to that formula? That's why I'm
You
asking.
do you either put it and say angular velocity is equals to theta over time. Then
Good. Find theta.
between
If you
cross
cross multiply,
multiply
what will you have?
between time and angular velocity, which is
Uh-huh.
10 times to 20.
Okay, I hope you know the 10 is already theta. Okay, so I did not want you to use these values here. It's only the formula I want you to manipulate. Let me see. And you have done that.
Okay.
Okay, good. Others, Shakiruddin, do you understand the question I just asked?
Yes, sir.
Very good. Vera, are you still with us?
Yes, sir.
You understand what I just said, right?
Yes, sir.
Okay, then who else? Who else is there that I'm not seeing? You know, I can't see you guys from here. Who else is there? Call yourself. Oh, all right. Let's go to another. Guys, solve this one for me now. Everybody, this question is yours. Let me enlarge. I believe you can see it from there. Solve this question for me. Find centripetal force. Okay, this FC now. It's not FC Barcelona. Centripetal force. Solve this for me quickly, quickly, quickly. Within 30 seconds, you can solve it.
Satisfied.
Okay, Shakiruddin's answer is that 45, right? Shakiruddin, is it 45? Emanuela, yes.
So is the answer 45?
Are you asking me? What is your answer? Will you ask your computer?
45, 45.
45 Newton. Vera, what is your
Yes.
answer? Who can tell me the formula? Which formula did you even use to get the 45? Vera, who has solved? Okay, Emanuela, which formula did you use? Shakiruddin, which formula did you use?
So I used centripetal force is equals to mv square over r.
Okay, yes, I'm waiting for one more answer. I'm waiting for one more answer.
Answer to what, sir?
Shakiruddin, you have given us your answer before. That is 45 Newton, right? Or you want
Yes,
to
sir.
change your mind? Okay,
Yes, sir.
okay. Then Vera, is Vera online?
45.
Okay, correct. All right, so it's 45 Newton. It's just mv square over r since it is centripetal force, and you already have mass 1.5 kg. Your velocity is 6, so it will now be 6 square. Your radius is 1.2. Everything divided by 1.2. You will get your answer. It's very simple. 10 seconds you can solve this. Okay. Aha. See a question. I don't know how many of you have seen RPM written on something. RPM. How many of you have seen RPM written on an object, something electrical? Some generators have RPM in them. How many of you? Nobody.
So I've seen it, but I've forgotten the value.
Okay. A rotating body turns at 120 RPM. That is revolution per minute. The meaning of RPM is revolution per minute. Okay, as that thing is rotating per minute, the count, if you are counting the rotation per 6, Sorry, please. Sorry for that break. I was asking about. Uh, hello, can you hear me? Hello, can you hear me now?
Yes, sir.
Okay, okay, thank you. I was talking about revolution per minute. So I said is the number of times a rotating body rotates in 1 minute. So this question says we should convert this 120 RPM to radians per second and then find angular velocity. Okay, that's the question. So we are going to solve now. Solution. So this one is not hard. You already know how to find angular velocity as long once you have everything you need in the question. I believe you can find angular velocity. So the only thing is conversion, right? How do you convert this to radians per second? Okay, so just look at it. I want to use this solution to explain something, especially if you are given theta in degrees, but this is not degrees. Let's start from here. 120 radians per minute is the same as you know 1 minute is equal to 60 seconds, and the question wants you to convert to radians per second. So that minute you are going to convert it to second. That's you divide by 60. Okay, that's the division by 60 there. Now, radians per means over. Okay, that is why it's over 60. Revolution per minute, it means over 1 minute, and 1 minute is equal to 60 seconds. That is why we are replacing the minute with 60 seconds now. Then 120 is still the 120 that is here. The 2 pi comes from the radians. When you are converting from revolution, you are converting to radians. Okay. Now, let me see. If I open another slide now, I want you to be seeing this while I'm doing what I'm doing.
Sir, I don't really
Yeah.
understand this
Don't
particular
worry, don't
one.
worry. It's what I'm still saying. I've not finished solving. I'm just starting, okay? We want to convert. Let's start from here. The question says we should convert 120 revolution per minute to radians per second. This 120 revolution per minute is 120 times. Now, you know that when something is in a circular form, let's use wall clock, a circular wall clock, for instance, as an example. A circular wall clock is 360 degrees. No, a circle is 360 degrees. Now, in some part of other mass, we do not use 360 degrees. Even some part of physics, when you are dealing with circular object, you call it 2 pi. Pi is equivalent to 180 degrees. Please, I want you to take note of that. Okay, let me say it again. I have to say that now so that for you to just understand. I wanted to say it later. Pi is equivalent to 180 degrees. Please write it down in case you forget. Okay, when you are dealing with radians and angle, you know that when something is rotating, it's rotating through 360 degrees. When something is rotating, it's rotating through 360 degrees. So if pi is 180 degrees, it means 360 degrees, which is a complete circle. 360 degrees is equal to 2 pi. Am I right? Are you still with me?
Yes, sir.
360 degrees is equal to 2 pi. That is just one revolution. 360. If I now have 120 revolutions, 120, so it will be 120 times 2 pi. Okay, so if it's as if you are saying the formula now is 100, and that is a number of revolution times 2 pi, which is 360 degrees since the thing is revolving in a circle. Then per minute means over time. Over time is still angular velocity. Okay, you are still dealing with angular velocity. It's just that the unit you are given is not radians per second. You are given in revolution per minute. You have to convert it to radians per second. So it's still over time. Remember that the formula for angular velocity is angle of rotation divided by time. It's still the same thing we are doing here now. Angle is 360, and how many times did that body rotate? How many times did it turn? 120 times. So that is 120 times 360. Okay. So the 360 is what I've represented as 2 pi. We can't write 360 here because you are dealing with radians. This is how you convert from angle to radians or from radians to angle. Don't forget that. So over time now, and our time is per minute. Okay, the equivalent of minute in seconds is 60. Do you understand it now? Hello. Hello.
Sorry, sir. Is it because
Yes,
of the
sir.
120 revolution per minute? That minute that is there. That's why we put 60.
Yes, minute. The 60 now is right. 1 minute is 60 seconds make 1 minute. Right?
Yes, sir.
Okay. So please, who can press the calculator for us? That is 120 times 2 pi. Pi is 3 point something. You know the value of pi, 3.142, right? So you use that. That's what you are going to use here. That's how you convert from angles to radians. I will explain it again. Let's just solve this one first. I'll use another question now. So press your calculator. 120 times 2 pi over 60. What are you going to have? Are my people there? What are we going to have? Hello?
Hi.
No, press calculator for me now. You don't have calculator there. Yes. Press the calculator. What are you going to
Sir,
have?
I'm more with my
So your answer is
tools.
720. 720.
No, I disagree.
So is it your answer
120
for the whole
times
question you're asking?
for the whole question, yes. 120 times 2 pi over 60.
12.6.
12, are you sure?
Yes, 12.6.
Does everybody agree with that? You know, 120 times 2 pi is okay. Let me simplify it in case you're still confused. It's 240 pi. 240 pi over 60. Over 60. So, and 240 pi means 240 times 3.142. Pi is 3.142. If you have done anything related to, circle, pi r square, all those things, over 60. Now press this one for me. 240 times 3.142 over 60. This is what I asked you to do.
Sir, 12.568.
12.568. So your answer is 12.
So it's not a
I can just
question.
say 12. Okay, ask, please.
So I was thinking that if I'm solving it, I'll now expatiate the pi as 180.
No, you won't do that because you have already you have converted from the uh, to 180 again. It means you are going back. You are going back to the original value. So that pi now is now, when you are dealing with radians, pi is representing that 180, but you use the normal value for pi in conversion.
Please, how can I get this value, this 3.142 for pi?
Just press pi in your calculator. Press pi. Scientific calculators normally have pi. And then if you just press pi, it will give you that value.
Okay.
It's a constant. It's a constant. 3.142 is a constant. 22 over 7, right? 22 over 7. And ask your question, please. Any other? None? Okay, let me ask now. You guys should solve this one for me. Should I dictate? Should I dictate?
Yeah, I'm not getting it though. I'm not fully understood it.
Okay. Which part? Okay, let me explain it this way. Let me go through it again. Now, when an object is rotating, anything rotating through a circle has an angle of 360 degrees, right? Circle, the angle, sum of angles in a circle is 360 degrees. Am I
Yeah.
right? So keep that in your mind. Yes. So if I now say a body or an object rotates, let's even just say once, let's use once for an example. Let's forget the 120 first. An object rotates one time like that. It means that object has gone through 360 degrees. Am I right?
Yes, sir.
Yes, sir.
If the object rotates twice, it means the angle will now be 2 times 360 degrees. Is that not so?
Yes, sir.
If it now rotates 120 times, so it means the angle will be 120 times 360. Am I right? Are you still following me?
Yes, sir.
Okay, 120 times 360. Since it's 120 times. The only thing I've done here now, because they asked us to convert, I told you in circular motion, you don't use angles like that. You don't write 360, you don't write 180. If you want to express your answer in the right way, which is angular velocity, radians per second, what you do is you convert that degree, you convert it to pi. And if I have just mentioned 360, and 360 is equal to 2 pi. So instead of writing 360, where I would have written 120 times 360, I will write 120 times 2 pi. Are you following me?
Yes, sir.
Good. So that is the 2 pi you are seeing. That 2 pi there has replaced 360. You are converting now from that degrees to radians. That's how you convert from degree. 1 pi, that's 3.142 is equal to 180 degrees. Do you
So
understand
this,
that?
this 3.142 is 2 pi.
No, it's 1 pi.
Okay.
Okay, do you know why I did not put the 2 here? I already multiplied 120 times 2 times pi. 120 times 2 is what will give you 240, all right? 120
Okay.
times 2 will give you 240. Is that not so?
Yes, yes,
You understand it now?
yes. Okay.
All right. So can I dictate my question?
Go ahead.
All right. Everybody is fine with dictation, right? Emanuela. Emanuela has gone offline. Okay, so since she's not here, let's dictate because I know she would want me to write it. Now, the question is this. Let's use a okay. Let me not use a complex stuff. A rotating object. A rotating object. I'm still repeating the same question. It's just the values that I'm changing. A rotating object revolves at, let's say, 50 rpm. Shakiruddin, are you still there? Okay. An object rotates at 20, did I say 20 or 50? 50 RPM. An object rotates at
So I said 50.
50, 50, yes. An object rotates at 50 RPM. Is that precious? 50 RPM.
No, sir.
Convert to radians per second. Convert to radians per second and find angular velocity. Convert to radians per second. So my angular velocity. Okay, first of all, convert to radians per second. Let me even see. Convert 50 RPM. 50 RPM. 50 RPM.
Sir, 5.23.
Okay,
So
your own
5.24.
5.24, 5.23. What's responsible for the 0.1 difference now? It's approximation, right?
Yes, sir. I approximated mine.
Okay. Yes, yes, yes. I'm waiting for the rest. I'm waiting. Shakiruddin. I'm waiting. Yes. What do you have? Is Shakiruddin still there with us? 50 RPM converts to radians per second. Okay, Vera, are you true? Are they still online? Are we still there?
Yes, sir.
Is it
Okay.
every question is used paper?
Okay. Shakiruddin, what did you say is your answer?
I said the pi. Is it every
Yes.
question like that we use to pi or we are going to determine another pi?
No, it as long as it's a circular motion, it's a revolution. It's 2 pi because it's 360 degrees. So that 2 pi must be there, all right? Did I answer your question? I did not hear you very well, though. Okay, so let me mention something else now. Okay, can we move on? Vera, can we move on? Hello, okay, let's move on. I wanted to say something. See now, uh, a question can express its answer. Like in the options, you can see answers that still contains pi. You can see an answer that, okay, you can have all the options containing pi in them, which means they did not change the pi to 3.142. For example, in this one we just solved now, there is possibility of changing. I can have something like this. Instead of writing 12.57 radians per second, remember that what I divided was 240 pi. Please pay attention to this one so that you don't get confused when you are not seeing when you are seeing pi in the options, okay? And your own answer is different without pi. Don't get confused, it's still the same thing. Now, 240 divided by 60 would have given me 240 over 60, that is 4. So I can say that if I still say that my answer is 4 pi radians per second, do you know that it's still the same thing as that 12.57 radians per second? The difference is that the pi here is still representing the 3.142. 3.142, okay? And 4 times 3.142 will still give you this 12.57. So if in the options, if the options you are having still contain pi, okay, you not change the pi to 3.142, you leave the pi like that. Many questions are usually like that. That's what I'm telling you now. Okay, but if they have written the value for the pi, if they use the value for the pi in the evaluation, you'll discover that there is no pi in there as part of their units in the options. Do you understand what I've just said?
Yes.
Yes, sir.
Okay, all right, thank you very much. Thank you very
Sorry,
much. So
I was
from
having
every
network issues. So my answer is
okay,
5.24.
okay, the question that I gave, right?
Yes, sir.
Okay, somebody should remind me, what's the question again?
So I can convert 50 RPM to watt per second.
Okay, 50 RPM. So who can explain?
So I can explain.
Okay, go ahead, explain.
Okay, so one revolution is equals to 2 pi or 360
Yeah,
degrees.
yeah.
So 50 revolution will be equals to 50 times 2 pi over
Okay,
60. Since they said revolution per minute, so over 60.
yeah, yeah.
So that gave me 5.24.
Okay. So Vera, you heard that, right?
Yes, sir. That's my
That is it
answer.
now. Yes, now you got it.
Oh.
Eh? You got it now. That is your answer. So I will clap for you later. All right, 50 times 2 pi. You know, I just said another way you can express that 5 point something radians per second you have is that you can still leave the pi there, which means I can have 100 pi over 60, 100 pi over 60, which would be something like 10 over 6, that is 5 over 3, that is 1.66666 pi. So you can have an answer that still contains pi in it, okay? It just means they did not input the 3.142 in place of pi. That is all. There is nothing different. Okay, so let's move on now. From everything we did in this circular motion now, if you are confused at any point, please ask. If you are confused, please ask. These are the formulas that we have been employing. Okay. Angular acceleration. You know that we said angular acceleration is equals to angular velocity over time. Okay, let me even allow you to ask question first. Ask question because I will ask. Ask question before we move on.
Sir, what was that formula that is V square over R?
That's where I'm going. That's why I said you should ask questions before I move on. So far, no question, right?
No, sir.
Okay. Now, angular acceleration can be calculated in two ways. Please pay attention. You can have a, let me enlarge this for, you can have change in angular velocity, that is delta omega over change over time, or your angular acceleration can be calculated as linear velocity square over radius. Please don't forget this. Don't forget this. Before you use this second formula, which is v square over r, before you use this second formula, v square over r, you discover that it is linear velocity that you are given in the question, not angular velocity. A linear velocity in the question. So that brings us to the relationship between angular velocity and linear velocity. There's a relationship between angular velocity, and linear velocity. The relationship between them is this: linear velocity is equal to angular velocity times radius. Please don't forget that relationship between angular velocity and linear velocity is that linear velocity is angular velocity times radius. I don't want to take you through how all these formulas are derived because these formulas are gotten from one another, okay? If you input this acceleration now, if you equate that one, we stress you, let me not confuse you. Let's just please put in mind that relationship between linear and angular velocity is this. Linear velocity is equal to angular velocity times radius. When and how do you apply this? Okay, so you can write. Can I dictate now? You know, these formulas for angular acceleration, we have used one, which is change in angular velocity over time. Okay, it's the second one that we want to apply now. Please, can I dictate?
Go ahead.
Okay. It's like my people are beginning to sleep. Wake up. All right. A body of mass 5 kg. A body of mass 5 kg moves in a circle. A body of mass 5 kg moves in a circle of radius. They can give you diameter. What's the relationship between diameter and radius? What's the relationship between diameter and radius? Who can tell us? Hello? Diameter and radius. You know that diameter is equals to 2 times radius. Diameter is 2 times radius, which means radius is diameter over 2. So if you are given, the reason why I'm asking is because you can be given. If you are given in diameter, just divide it by 2 to get your radius so that you can use it. They can say a body rotates through a circle that has a diameter of, they will give you diameter, not radius. They are just trying to check whether you know what they are saying. Okay, so let's continue. A body of mass 5 kg moves in a circle of radius 2 meters. Radius 2 meters at 5 meters per second. At 5 meters per second. At 5 meters per second. Calculate. Calculate. Okay, let me write the question here because I was sort to a body of 5 kg moves through a circle of radius, moves through a circle. Are we still together?
Yes, sir.
Okay, 2 meters. And at 5 meters per. What's the velocity that I gave? Is it 5 meters per second?
Yes, 5 meters per second.
Okay, at 5 meters per second. Calculate. Number one, right now. Calculate. 1. Centripetal force. Centripetal force. Okay, let me say centripetal acceleration or angular acceleration is still the same thing. Okay, centripetal acceleration. So this formula that I wrote here now, please, you can see, call it your centripetal acceleration. Okay, so centripetal acceleration centripetal force three angular velocity. Angular velocity. That's the question. Once I solve this now, you don't have any challenge with circular motion. So let me solve. Is there anybody who wants to solve it for us? Anybody? Okay, solution. Mass. You have been just know the values you are given in the question. Mass given to be 5 kg. Radius given to be 2 meters. Velocity, that is linear velocity. If it is angular velocity, you'll be
Sir,
given
the
in
first
radians
one is
per.
12.5.
Wow, okay. Continue, solve the rest, be solving the rest. You confirm using my own solution. Oh, yeah. Velocity 5 meters per second. That's linear velocity. Okay, how do I know it's linear velocity? It's only linear velocity that is meters per second. Angular velocity is radians per second. So the first question says I should calculate for centripetal acceleration. Centripetal acceleration A is equals to V squared over
Sir,
R.
the second one is 62.5.
Okay, proceed to the third. V square, and my V is 5. 5 square over 2. 5 square is 25. That is 25 over 2, which will give me 12.5. 12.5 meters per second square. Okay, that's centripetal acceleration. Now, centripetal force. Of course, everybody can calculate centripetal force. I just combined all the questions together in one. That is just to explain. Centripetal force is equals to mv square over r, right? Centripetal force is mv square over r. So centripetal force is mv
Sir,
square
angular
over r.
velocity is 2.5.
Okay, mv square over r. So r, the question was 5. Velocity was given also to be 5. That is 5 times 5 square. Radius was given to be 2. That is 5 times 25 divided by 2. 5 times 25 divided by 2. That's 102. 125 divided by 2 will give you 60, 62.5. Am I right?
Yes.
Okay, 62.5 Newton. That's the second question. Then the third question, question number 3 says you should calculate the angular velocity. This one is the second question. So the angular, I told you angular velocity. If you want to use, see the formulas that you can use. But I want to show you something. Let's go back to the beginning. If you look at the beginning, one of the formulas you can use for angular velocity is theta over time. Theta over time. But in this question, there is no theta. They did not mention theta, they did not mention time. So it means you can't use that formula. So what are you going to do? You use that relationship between angular velocity and linear velocity. Remember that the relationship is V, relationship between angular velocity and linear velocity. V is equal to angular velocity times radius. So you remember that you've already gotten Linear velocity has been given in the question to be 5 meters per second. Linear velocity has been given in the question to be 5 meters per second. So that is 5. Your V now is 5. So 5 is equal to angular velocity times radius was given to be 2. So just make your angular velocity the subject. Angular velocity is equal to 5 over 2. If you divide both sides by 2, 5 over 2, then you have your answer. Angular velocity is equal to 2.5. What's the unit for angular velocity? Radians per second. So this is the relationship between linear velocity and angular velocity. So you can have a question that will give you angular velocity, and they will ask you to calculate linear velocity. Are we together?
Yes, sir.
Hello? Okay. Any question, please ask.
No question.
Okay. Yes, others, please ask your question. Ask your question. Emanuela, any question?
Sir?
Do you have any question?
No, sir.
Vera, do you have any question?
No, sir.
Hello, hope you are still with us. All right, let's move on. If there is no question up to this point, we can now proceed to another topic. We can proceed to a new topic. At least let's get to introduce a new topic tonight. All right. We want to look at temperature and its measurement. Temperature and its measurement. Okay. It's not a complex topic. It's just a very simple calculation there, and we are done. Temperature and its measurement. Okay, so of course they will not ask you to define anything. They will not ask you to define temperature and all of that. But temperature is the degree of hotness or coolness of a body. We all know that before, okay? But there are things that I want you to pay attention to. Things like how does temperature affect kinetic energy of particles, okay? Please don't forget that. Higher temperature leads to higher movement or motion of particles, okay? Higher temperature leads to higher kinetic energy. Don't forget, when the temperature of any matter, whether it's a liquid, whether it's a solid, whether it's a gas, when the temperature of any matter is increased, what will happen is that the particles will begin to move. The particles will move faster than they were before the increase, okay? Now, that is motion. Kinetic energy has to do with motion. Okay, so that is movement. Movement. Higher temperature leads to faster movement of particles or higher average kinetic energy, which means if I want to increase the kinetic energy of the particles in a matter, I should just increase the temperature. Lower temperature leads to slower movement of particles and lower average kinetic energy. Those are the two things I want you to take note of here. Okay, higher temperature is equal to higher average kinetic energy. Lower temperature leads to lower average kinetic energy. Don't forget that. Temperature is a scalar quantity. A scalar quantity. Don't forget, it has only magnitude, no direction. Okay. Temperature is a scalar quantity. The SI unit of temperature is degree, is Kelvin. Kelvin, but the commonly used unit is degrees Celsius or centigrade as we used to call it. But the SI unit is Kelvin. And there's a relationship between this Kelvin and Celsius, degrees Celsius. Okay, we'll see that. Let's leave that for now. Different permissions. There's because usually you can have questions that require you to convert from one scale to another scale. It may not be just Kelvin and Celsius. You can have Fahrenheit. You can be asked to convert from degrees Celsius to Fahrenheit or even from Kelvin to Fahrenheit and vice versa. Okay, so note, two bodies at the same temperature, two bodies at the same temperature are said to be in thermal equilibrium. Don't forget that. Two bodies at the same temperature are said to be in thermal equilibrium. Like if you and I have the same body temperature, we are said to be in thermal equilibrium. There is no net heat flow between us. Okay, but if one object has lower temperature and another object has higher temperature, there's going to be heat flow. Okay, heat will flow from the one that has the higher temperature to the one that has the lower temperature. But if the two objects are the same temperature, they are in thermal equilibrium. Please don't forget that. So thermal equilibrium just means bodies that are the same temperature. So I will combine this subtopic with the types of thermometer. What is a thermometer? You can't talk about temperature without mentioning a thermometer. A thermometer is an instrument used to measure temperature, degree of hotness or coldness of a body. So there are different types of thermometers. Okay, we'll see those different types now and what they are used for. So as I'm explaining thermometric properties, you see how it determines the kind of thermometer that you have. A thermometric property is any physical property of a substance that changes regularly and measurably with temperature. Okay. Examples of thermometric properties, you have length of a liquid column. Like you can have liquid. There are certain liquids that are thermometric in nature. For example, mercury. Mercury is thermometric. It changes. That's what I mean. The physical property of mercury can change if temperature is changing. The same thing with alcohol. They can expand. That's why they are used in clinical thermometers. Okay. Used in liquid in glass thermometers, e.g., mercury or alcohol thermometers. So this length of a liquid column is used in liquid in glass thermometers. I want you to note the type of thermometer and the thermometric property. Length of a liquid column is used in liquid in glass thermometers. An example of liquid in glass thermometers, you have a mercury or alcohol thermometers. As temperature increases, any of this liquid, whether it is mercury or alcohol, will expand and its length in the capillary tube will increase. That's why once you put thermometer on yourself, okay, you can measure your own temperature. You discover that the liquid will begin to move. Okay, it's expanding. That is it. That is why it's increasing in length. It's because of the expansion. All right. That is length of a liquid column. Then another is electrical resistance of a metal. Electrical resistance of a metal. This thermometric property is used in resistance thermometers. Resistance thermometers. Okay, for most metals, resistance increases with temperature. Don't forget that. For most metals, resistance increases with temperature. That is, the higher the temperature, the higher the resistance. That is why you discover that during when the weather is very hot, especially during dry season, when the weather is very hot, it can affect the light, like the current that your household can receive. Why? Because the resistance will be very high. As long as the resistance is high, the current is going to be low. Okay, then another thermometric property is electromotive force, EMF. Normally is in thermocouple thermometers. I just told you that note the thermometric property and the kind of thermometer it is used in. All right, then another thermometric property is volume or pressure of a gas at constant pressure or constant volume. This one is used in gas thermometers. Gas thermometers. I've mentioned 4 different kinds of thermometers now. You have liquid in glass thermometer, you have resistance thermometers, you have thermocouple thermometers, and you have volume, that's gas thermometers. Yeah, that uses the thermometric property of volume or pressure of a gas. Okay, then calibration of thermometers. How are thermometers calibrated? How are thermometers calibrated? They are calibrated using what we call upper fixed point and lower fixed point. Upper fixed point and lower fixed point. Okay, let me remove this equation here so that you not confuse you. I will explain it once we get there why is that way. Now, upper fixed point is usually the boiling point of water. Okay, the boiling lower fixed point is called ice point. Okay, let me write it. Ice point. Ice point is the lower fixed point. Okay, for all the scales of temperature, lower fixed point. While steam point is the same thing as the boiling point of water. Steam point is referred to as the upper fixed point. Now, when you are dealing with water, the lower fixed point, the ice point is 0 degrees Celsius, while the boiling point is 100 degree 100 degrees Celsius. Are you still following me?
Yes, sir.
Are you there? Okay, thank you. So don't forget these 2 points now. This is how with upper fixed point and lower fixed point. Upper fixed point is steam point, lower fixed point is ice point. Now, if you check, you see that the scale I've used here is Celsius, degrees Celsius. What if we want to change it to Kelvin? Now, in Kelvin, of course, that will be, 0 degrees Celsius is same as 273 Kelvin, while 100 degrees Celsius is the same thing as 373 Kelvin. Who doesn't know how I got those Kelvin values? Is there anybody who doesn't know how I got the Kelvin values? Anybody? There's a relationship between degrees Celsius and Kelvin. The relationship is that you add 273 to Celsius to get Kelvin. Okay, what I mean by that is this. Let me not assume that we all know it. If I want to convert the temperature from Celsius to Kelvin, so temperature in Kelvin is equal to temperature in degrees Celsius. Temperature in degrees Celsius plus 273. 273, okay? The conversion from Celsius to Kelvin. You just add 273 to say, for example, if I ask you to convert 5 degrees Celsius to Kelvin, 5 degrees Celsius to Kelvin, you will just say temperature in Kelvin is equal to 5 degrees Celsius, 5 degrees Celsius plus 273. So it means 5 degrees Celsius is equal to 278 Kelvin. Okay, that's that. Please don't forget that. So let's move on. Temperature scales. Oh, is what I've just explained now. Temperature scales, I've explained that. Okay, ice point, steam point, conversion. Then types of thermometers, I've mentioned them also with their thermometric properties, is what I've just mentioned. You have liquid in glass thermometer, clinical thermometer, which is still an example of liquid in glass thermometer. Yes, gas thermometer. This is the thermometric property, constant pressure and volume. Then thermocouple thermometer, resistance thermometer, and thermistor. Thermistor and resistance thermometer uses the resistance of metals. Okay, then temperature conversion now. I think I've said something about that. Yes, temperature conversion, I've said something about that. Let's
Sorry,
now,
sir. Sorry, sir.
yeah,
Please. Thermocouple uses what?
please come again.
I said thermocouple uses what for his
Okay, it uses the
measurement?
thermometric property of EMF, electromotive force.
Okay, thank you, sir.
All right. Okay. Any other question before I move on?
Sir, please, can
Okay.
you go back to that place where you listed the types of thermometers? Abi,
Oh,
yes.
okay. Where is it? This is it. Are you seeing it?
Okay, sir. Thanks, sir.
All right.
Sir, please, what's the thermistor?
Thermistor is used to still measure resistance, especially if you are dealing with. It depends on. Let me say, you know what a resistor is, right?
Yes, sir.
What's a resistor?
It's an electric device that provides resistance to the flow of current in an electric circuit.
Oh, very good. What's resistance?
It's the ability of the resistor to oppose the flow of current in the circuit.
Okay, okay. Ability of the resistor. Hmm. Well, you got it. You could just say is the opposition to the flow of current. That is resistance, opposition to the flow of current. So thermistor measures, you know that the temperature, okay, at which resistance happens, all right? It measures the temperature at which the resistance happens, or the temperature in the resistor. Okay, the temperature. Don't forget, I said resistance thermometers or thermistor, they use the thermometric property of resistance of metals with respect to temperature. Resistance of metals with respect to temperature. When the temperature is increasing, the resistance will be increasing. So the device that measures the temperature itself is called the thermistor. Is that okay?
Yes, sir. Thank you, sir.
All right. Uh, I want to see if we can solve at least one question. This one is very simple. I'm looking for something that asks serious questions. Okay, these are UTME questions. What thermometric property does a thermocouple use? It's very simple. EMF. A thermometer reads 300 Kelvin. Find the degree Celsius temperature. Okay, a thermometer reads 300 Kelvin. Find the degree Celsius temperature. I don't think this one should be hard for anybody. A thermometer reads 300 Kelvin. That's the temperature in Kelvin. I've just given you a formula that temperature in Kelvin is temperature in degrees Celsius plus 273. So if you are now looking for degrees Celsius, it will be temperature in minus 273. Okay. Then, okay, I've just answered this one. Then this one says identify the upper fixed point of a Celsius scale. That is 100 degrees Celsius. Then this one is still the same. See, this one is just, there is a question I'm looking for. I saw a particular question today. Okay, yes. Let me show you that question. Okay, it's not in the slide. This question, I have some UTME questions here. Let me just give you one or two before we go off. Now, this one is Fahrenheit now. Who knows how to convert from, okay, this one that we have done now, let's do that. We've not done the conversion to Fahrenheit, but let me let me ask you a question now. This number 4. We'll still treat all these things. When we complete this topic, you can answer any of these questions under temperature and measurement. But this is the question I want to show you. This number 4. Please write it down. Let me dictate it to you, and then you write, and then I will solve it for you to see. Because such question is very common. The height of the mercury thread. The height of the mercury thread in a tank. Okay, let me copy it from here and just paste it on the, so that you can see it very well. So this is the question. This is the question here. Please write it down so that we can solve now within the next few minutes. The height of the mercury thread in a mercury in glass thermometer. Okay, mercury in glass thermometer, that is liquid in glass. That's the thermometric property. When in melting ice and then in steam are, no, that melting ice, it means ice point. Okay, that's what they are saying. And then in steam, that is steam point, are 3 centimeters and 18 centimeters respectively. This UTME past question. At a temperature of 60 degrees Celsius, the height will be what? At a temperature of 60 degrees Celsius, what would be the height? Well, once you are through writing, let me know so that I want all of you to listen to me so that I will explain. Once you understand my explanation, solving it will not be a problem. This is the only question that can give you a little stress under temperature and its measurement. That's why I'm bringing it out. Are we together? Hello, are we together?
Yes, sir.
Okay. Are you done writing? Because once I go to the new slide now, I won't see this question. You'll be the one helping me with the question.
Sir, please wait.
Okay. Okay. Can I move on?
Yes, sir.
Okay, very good. So please, you'll be responding to whatever I ask now because I won't be seeing the question, so I will depend on you. Can I depend on you?
Yes, sir.
Okay. So now I depend on my wonderful students now. So looking at that question, you discover that there is a simple, you are having two things there. You are having temperature and you are having length. Am I right? Or height, as it is, length and height, whatever. So please keep that in mind. Now the temperatures that you were given, you have under temperature, please be following me. On temperature, you have ice point and steam point. What's your ice point? Who can still remember ice point?
0 Celsius.
Okay, 0 degrees Celsius. Please don't forget, ice point is always 0 degrees Celsius. Then what of steam point?
100 degrees Celsius.
Okay, 100 degrees Celsius. You can see that they did not give you those values. They did not mention 0 degrees Celsius and 100 degrees Celsius in the question. They expect that you already know them. Please don't forget. So steam point is 100 degrees Celsius. So let's go to height now, or length. The length, what was given in the question? They said they mentioned some lengths respectively. Am I right? What are those heights in the question?
So I not put it on my.
Let me go back to the question now. Is there?
Okay.
They said are 3 centimeters and 18 centimeters respectively. Is there now? 3 centimeters and 18 centimeters respectively. So it means at ice point, the height is 3 centimeters. At ice point, the height is 3 centimeters. Then at steam point, what's the height at steam point?
So the answer is 12.
Okay, what's the
Eight,
height at steam point?
18 centimeter.
Okay, 18
18.
centimeter. Okay, 18 centimeters. Good. So the question now says at 60 degrees Celsius, what would be the height, right? So at 3 centimeters, at 0 degrees Celsius, the height is 3 centimeters. At 100 degrees Celsius, the height is 18 centimeters. So what will it be at 60 degrees Celsius? Somebody mentioned 12 just now. Please, do you mind telling us how you got the 12?
Yes, sir. I did
Okay.
H minus the, like, H is what I'm looking for. That's height I'm looking for.
Mm, mm,
Minus the lower the ice point over steam
mm.
point minus ice point. That's H minus 3 over 18 minus 3. And I equaled everything to 60 minus the lower point of Celsius. That's 0. 60 minus 0 over 100 minus 0. That's steam point minus ice point. And then I got 12.
Okay, good. All right, so let me explain what she just said now, so that none of us will be confused. Now, there's a relationship between this temperature and length, okay? 3 corresponds with 0 degrees Celsius ice point, 18 corresponds with 100 degrees Celsius. Now, 60, what is the length of 60, okay? So 60 now is what they're asking us, what's the length, what's the height, rather? We don't know. So whatever ratio we do, whatever we do with temperature, we are going to do the same with length. Okay, don't forget there is unknown. We are looking for unknown length now. We are given a particular temperature of 60 degrees Celsius, but we don't know the length, which we are asked to calculate the length of the thermometer. So we can say is X. Okay, X. So whatever we do with temperature, we are going to do it with length. So what she just said is correct. So this is what we are going to do. We are going to find the difference. I wish I can show you a thermometer and be touching all the calibrated marks for you to see. But just imagine you are looking at a thermometer that has 0 degrees Celsius, 100 degrees Celsius, in between 60. Then, and the length is 3 centimeters at the ice point, 18 centimeters at the steam point, in between X. That X corresponds with 60, which we are looking for, okay? So that's with respect to temperature now, I can say my 60 minus 0, that's the temperature whose length we are looking for, minus ice point in a bracket, over steam point minus ice point, temperature whose length or height you are looking for minus ice point over steam point minus ice point is equal to length you are looking for, that is x, minus the length at the steam point. You know, look at my temperature side, my left hand side now. It can be any side, you can put it at the left or at the right, it's still the same thing. But what I did at the temperature side is the temperature with the unknown height minus steam minus ice point. So I am doing the unknown height minus height at the ice point. That's it. Look at the temperature side again, the denominator, steam point minus ice point. So I will do at the right hand side now, which is for my height of the mercury in the thermometer, will be temperature height at the steam point minus height at the ice point. Okay, you remember that I told you whatever you do with the temperature, you will do with the height. Okay, 60 minus 0 means known temperature with unknown height minus ice point. Then at my height side, unknown height, that unknown height minus the height at the ice point. Okay, temperatures, each temperature has its height in the thermometer. Each temperature has its height in the thermometer. Okay, 60 is the height we don't know. That's why this x at the right hand side is it corresponds with 60 at the left hand side. This 3 at the right hand side correspond with 0, which is the steam point at the left hand side. Then 18 at the right hand side is the height of the 100, that is the steam point. 3 is still the height of the ice point. So if you solve this now, you are going to get your answer. So that is 60 over 100 equal to x minus 3, everything divided by 18 minus 3, that's a 15. So 60 over 10, 60 over 100, we do 6 over 10, that's 3 over 5. 3 over 5 is equal to, somebody should press calculator for me now. 3 over 5 is equal to x minus 3 over 15. So if you cross multiply, okay, you can even divide through, but let me not jump. If you cross multiply, you are going to have 5 times x minus 3 is equal to 15 times 3. So if I open the bracket, that is 5x minus 15 is equal to 45. So 5x, if I make it the subject, is equal to 45 plus 15. 5x is equal to 60. So 5, divide both sides by 5. I'm going to have x is equal to 60 over 5, which is 12 centimeters. So it means the height of the temperature. When the temperature is 60 degrees, the height of the mercury rather, when the temperature is 60 degrees Celsius, the height of the liquid, that is mercury in the thermometer, is 12 centimeters. Yes, ask me your question. Ask me your question. They can, you know, here now is height they ask you to look for. but they can change, they can give you all the heights, the three heights, and give you only two temperatures and ask you to find the temperature. It's still the same method. It's still the same method. Yes, ask me your question. Ask. I did, yeah.
Yes, sir.
Okay. Please, if you have any question, ask Shakiru, Dean, Vera, Emanuela. Is it Precious? Who have I not called now? If you are there and you have any question, ask, please. Nobody has any question. I'm expecting questions. Okay. Emanuela.
Star.
Okay. Are you the only one online? Who else is online with you? Let me know.
There's four others now.
Wow.
Shakiri is here. Vera is
Yes, I'm
here.
online.
Shakiruddin. Okay. Vera is still online also. Yes.
Yanu Oluwa.
Iyanu Oluwa, you have been there. I did not know. You are welcome. Yes. Shakiruddin, any question?
No, sir.
Vera, any question?
No, sir.
Okay, because you guys are going to solve one question like right now. Now. Should we? Should we solve one question?
Yes, sir.
Iyanu Oluwa, are you with us? Iyanu.
Yes, sir.
Okay, Iyanu is there. So everybody agrees that we solve one question, right? Okay, this is a question. This question. Now, remember, let me explain this, okay, in case you are confused anywhere. Whatever you do at the side of the temperature, you do at the side of the height, okay? Irrespective of what is, it can even be two different scales. You know, it's temperature and height now, but you can even be given two different scales. It can be degrees Celsius and Fahrenheit. It's still the same thing that you will do, okay? You are usually trying to relate three things at the side of the temperature and at the side of the height. So what I did here is that the temperature, I have three temperatures, okay? The second temperature, which is between 0 and 100, is 60. So that second temperature minus the lowest temperature, that's the ice point, over the highest temperature, steam point minus ice point again, is equal to height at that second temperature, which I don't know and I'm asked to calculate, height at that second temperature minus height at the steam point. You know, steam point is 0 over height at the ice point is 0. Height at the steam point is 18 minus height at the ice point. Okay, so that is it. There is no special formula. It is, in fact, I can still change this thing in a different way and I'll still get the same answer, but let me not confuse you more than this. Okay, so this is the question. The height of the alcohol in a thermometer, the height of the alcohol in a thermometer. Are you writing? Are you writing? Are you writing? The height of the alcohol in a thermometer. Oh, sorry. at ice point and steam point are 5 centimeters and 80 centimeters respectively. Calculate the height of the alcohol at 45 degrees Celsius. That's the question. Very simple question. 45 degrees Celsius. Can we all see the question? Can we see the question? Hello, hello. Have we written the question? Has everybody written down the question?
Yes, sir.
Okay. Emanuela, you've written down the question, right?
So I'm on my way home, sir.
Emanuela is on her way home. Okay. Yes. Vera, have you written the question? Iyanu Olua. Iyanu. Okay, Shakiruddin, solve it quickly and tell me what you have.
What do you say, sir?
What did you say?
I said, what do you say?
Solve the question. Let me know what you have.
Okay, sir.
You have 2 minutes. Very simple question. That's the temperature you are asked to calculate its height.
38.75 centimeter.
Okay, 38.75 centimeters. Okay, explain to me. Does your expression look like my own at the beginning?
Yes, sir.
All right. So that is the temperature whose height you are looking for minus ice point over steam point minus ice point is equal to the height you are looking for minus the height at ice point over ice at steam point minus height at ice point. Height at steam point minus height at ice point. That is all. Once you're able to get the expression correct, your answer will be correct. All right, we are going to stop here tonight. I'll stop here tonight. I will send this note to the group so that we can go through it once again and ask questions where necessary. Have a wonderful night.